Joints, also known as articulations, are the points where two or more bones come together. They allow movement and provide stability to the skeletal system. Joints vary in structure and function, and they are classified into different types based on their structure and the degree of movement they allow. Here's an overview of the anatomy and physiology of joints in the human body. Anatomy of joints. Fibrous joints. These joints are characterized by the presence of fibrous connective tissue between the bones. They allow little to no movement. Examples include sutures in the skull and syndesmoses, ligamentous joints, between certain long bones. Cartilaginous joints. These joints have cartilage between the bones, which provides some flexibility. There are two types of cartilaginous joints. 1. Synchondroses. These are temporary joints where hyaline cartilage connects the bones. 1. An example is the epiphyseal plate in growing bones. 2. Symphyses. These joints have a pad of fibrocartilage between the bones. 2. The intervertebral discs and the pubic symphysis are examples of symphyses. Synovial joints. These are the most common type of joint in the body and are characterized by a synovial cavity between the articulating bones. Synovial joints allow a wide range of movement and are further classified into 6 types based on their structural features and movement they allow. 1. Hinge joint. Allows movement in one plane, like the elbow joint. 2. Pivot joint. Allows rotational movement, like the joint between the radius and ulnar in the forearm. 3. Ball and socket joint. Allows movement in multiple planes and rotation, like the hip and shoulder joints. 4. Condyloid, ellipsoid, joint. Allows movement in 2 planes, like the wrist joint. 5. Saddle joint. Allows movement in 2 planes, with greater range than a condyloid joint, like the joint at the base of the thumb. 6. Gliding, plane, joint. Allows sliding or gliding movements between flat surfaces, like the joints between the bones of the wrist and ankle. Physiology of joints. The primary function of joints is to facilitate movement while providing stability to the skeletal system. This is achieved through the following components and processes. Articular cartilage. This smooth, slippery cartilage covers the ends of bones within synovial joints. It reduces friction between the bones and absorbs shock during movement. Synovial membrane and fluid. The synovial membrane lines the joint capsule and secretes synovial fluid. This fluid lubricates the joint, nourishes the cartilage, and provides a cushioning effect. Joint capsule. The joint is surrounded by a tough, fibrous joint capsule that helps hold the bones together. It also contains ligaments that reinforce the joint and provide stability. Ligaments. Ligaments are strong bands of connective tissue that connect bone to bone, providing stability and limiting excessive movement. Muscles. Muscles play a crucial role in joint movement. They contract to generate the force required to move the bones around the joint. Tendons. Tendons are tough connective tissues that attach muscles to bones. They transmit the force generated by muscle contractions to the bones, resulting in joint movement. Synovial fluid circulation. During movement, synovial fluid circulates within the joint, providing nutrients to the articular cartilage and removing waste products. Nerves and proprioception. Joints are richly innervated with sensory nerves that provide information about joint position and movement to the central nervous system. This proprioceptive feedback is essential for maintaining balance and coordinating movement. In summary, joints are essential for human movement and function. The diversity in joint types allows for a wide range of movements while maintaining stability and protecting the bones from damage.